This is a short video lesson on stoichiometry. Just a quick reminder of the basic steps and an example. So with stoichiometry in general, there's 4 basic steps to do most stoichiometry problems. So the first basic step in most stoichiometry problems is to identify the chemical equation, right? So identify all the reactants and products and balance them. Second step, calculate the moles of our known value. So there's usually something that we know enough about to find the moles. Third step is to use that mole ratio to find the moles of the unknown. And the last step is to convert moles into whatever units it is that you're looking for. So all these calculation steps can be done with dimensional analysis. And a quick reminder on dimensional analysis, that is using our conversion factors and canceling units so that we end up with the units that we want, as opposed to calculating using formulas. It's a little more compact way of showing it. So if we have this first example, 30 grams of ethanol is burnt in a complete combustion reaction, what mass of carbon dioxide is produced? So step 1, write the balanced chemical equation. So ethanol being burnt in a complete combustion reaction, so any combustion is our fuel plus oxygen. So in this case, ethanol plus oxygen. And it produces, for complete combustion, carbon dioxide and water. Incomplete combustion, that could be carbon monoxide or carbon, but this is complete combustion. So that's not balanced. In order to balance it, we need to start with our carbon or hydrogen and end with our oxygen. So we have 2 carbons on this side. We're going to need a 2 on this side. We have 5 plus 1, so 6 hydrogens on this side. We're going to need 6 on this side, so since we have 2, we can multiply that by 3 to give us 6. Now, our oxygen is last. We have 4 oxygen in our carbon dioxide plus 3 oxygen in our water, which is 7 in total. Remember, on this side we've got 1 in the ethanol, so we need 6 more in the oxygen itself, so we'll put a 3 there to give us 6 oxygens. So if we look at what we know in this question and what we're being asked for, we know we've got 30 grams of ethanol, and we want to know the carbon dioxide, the mass specifically. So we're looking for mass over here on carbon dioxide. So if we look at the procedure here, so far we've done step 1, we've identified what our known is, so we can figure out how we convert that to moles. So if we have 30 grams of ethanol and we want to convert to moles, we need to use what's called the molar mass. Remember, molar mass comes from our periodic table, and if we have a compound, we need to add up the individual parts of our compound. So in this particular case, our compound is ethanol, so that's 2 of the carbons, which is 12.01. 6, because don't forget that it's 5 plus 1 of the hydrogen. And 1 oxygen. So we add those up, we get the molar mass is 46.08 grams per mole of ethanol. So the fact that we have this unit that's grams per mole, that tells us the number of grams that equals 1 mole. So with dimensional analysis, we can take those sorts of units, something per something else, and put them in a fraction, either with 46.08 grams on top and 1 mole on the bottom, or vice versa, with 1 mole on top and 46.08 grams on the bottom. So if we look at our units here, because we're going to use dimensional analysis, we want to cancel out the grams. So we want to put that molar mass, the grams, in the bottom of our fraction. Whoops, and I put 2 multiplication signs. Don't want that. So this way our grams are going to cancel out and we're going to be left with moles. So we've done that first step, which is convert, the first calculation step that is, which is convert our given amount to moles, right? If we stopped right now, we'd be at moles of of ethanol. So the next step, use mole ratio to find moles of our unknown. So our mole ratio always comes from our balanced equation. That's why we had to do that first. So we're taking our known value, 1 mole of ethanol, to our unknown value, 2 moles of carbon dioxide. And again, we have to look at which way we want to put that so that the right things cancel out and we're left with the correct things. So we want to cancel out the ethanol and replace it with carbon dioxide. So ethanol is going to go on the bottom and carbon dioxide is going to go on the top. So 2 carbon dioxide to 1 ethanol. And then our last step is to convert back to the units that we want. So again, this is looking at mass. So we're going to need molar mass of carbon dioxide. So add up 2 oxygens and 1 carbon. We get 44.0 grams per mole. This time we want grams on top to cancel out our moles. And I should show my canceling here as well. So the ethanol cancels here. The moles cancel here. If we look at what we're left with units, we've got carbon dioxide and we've got grams. So our final answer is in grams of carbon dioxide. So we calculate this all out. 30 divided by 46.08 times 2 divided by 1, which we can skip because it's 1, times 44.01. And we get an answer with lots of extra digits if you're doing it in your calculator. But if we look, we started out with 3 sig figs. Our molar masses are to 4 sig figs. So going by our least sig figs rule when we're multiplying and dividing, we round this to 3 sig figs and we get 57.3 grams of carbon dioxide for a final answer. So there's your basic steps of stoichiometry.